Hi everyone, I hope you're having a great day today. The topic for today, and the last one in Chapter 7, is percentage composition. Basically, if you have a compound, say water, H2O, what percentage of water, of a water molecule is hydrogen, and what percentage of that water molecule is oxygen? What percent composition does is, if we know the mass of each element in the compound and the overall molar mass, we can figure out the percentage of each element in that compound. Basically, you're just finding a percentage. To find the percent of the element in the compound, say the hydrogen in the water, we would have to know how much hydrogen there was in the element, which there's 2 hydrogens, and the mass of that would be 2.02. And we would need to know the overall molar mass of the compound. This is mass of the compound, that's the overall molar mass. And then we would multiply that by 100. So the unit for percent composition is a percentage. So let's look at 3 example problems. The first one is to find the percent composition of each element in carbon dioxide. You're going to have to know what the formula for carbon dioxide is. It's molecular, so we're going to be using our prefixes, 1 carbon and 2 oxygen, so the formula is CO2. And then we're going to list the elements, what their individual masses are, and then we're going to add them up to find the molar mass, just like before. So we have 1 carbon at 12.01. We have 2 oxygen at 16, so a total molar mass of 44.01. So on the molar mass line, we're going to add in the units, grams per mole. You should add your units into your work, but for right now, I didn't have space. So first, we're going to look at the work for finding the carbon. We need the total mass of the carbon divided by the total molar mass of the carbon dioxide. So to find that, we know that we had 1 carbon at 12.01. The total molar mass is 44.01 times 100, and we have 27.289. We'll add our unit later. The next one we're going to do is look at the work for finding the percentage of the oxygen. In this case, if you look at the molar mass, we had 2 oxygens for a mass of 32.00 total, and the molar mass of 44.01. Now the mass of the the percent of the carbon and the percent of the oxygen, those should equal 100%. So let's look at sig figs for carbon. We have 4 and 4. For oxygen, we have 4 and 4, so both of our answers should be in 4 sig figs. So for the carbon, we're going to round that to 4 significant figures, and our unit is a percent. And we'll put the symbol of carbon afterwards. For the next one, for the oxygen, again, we need 4 significant figures. The unit will be a percentage. Now those two should equal 100%. Okay, the next example is to look at finding the percent composition of each element in copper 2 hydroxide. Copper 2 hydroxide is an ionic compound. Copper has a +2 charge, so it's a Cu +2. Hydroxide is a polyatomic ion. It's an OH -1, switch and drop. So your formula for copper 2 hydroxide is Cu parenthesis OH parenthesis 2. We're going to list our elements. We have carbon, we have oxygen, and we have hydrogen. Remember that the 2 outside the parenthesis goes to both the oxygen and the hydrogen. So we're going to show the work for calculating the molar mass. 1 copper, 2 oxygen, and 2 hydrogen for a total molar mass of 97.57 grams per mole. Now in this case, excuse me, we have 3 elements. So first let's find the percentage of the copper. Our total mass of the copper is 63.55 over the entire molar mass of 97.57 times 100%. We have a percentage of 65.1327. The next one is the oxygen. Our total mass of the oxygen in the copper 2 hydroxide is 32.00 grams. Our total molar mass multiplied by 100. We have our percentage of the oxygen. We'll look at sig figs in just a moment. Now both of those would be 4 significant figures. The last thing we need to figure out is the mass of the percentage composition of the hydrogen. The hydrogen has a total mass of 2.02 over the entire molar mass of the copper 2 hydroxide. Now in this case, we're only going to have 3 significant figures. So let's pull down our answers onto our answer line. Our first one, we need 4 significant figures, so we're going to round that appropriately. with the unit of a percent with the symbol copper afterwards. We need 4 significant figures for the percent of the oxygen. Again, rounded appropriately to 4 significant figures, and our unit would be percent and then the oxygen symbol. And then the hydrogen, we have 3 significant figures. So 2.07% of this compound is hydrogen. Now, how else can this be useful, say in the world of chemistry? Well, we have a compound, gold 3 chloride. I have 500 grams of that. Part of that is gold. Gold is a very expensive element. How much of those 500 grams would be gold if I can extract the gold from the gold 3 chloride? So what we need is only the percent of the gold in this case, and then we'll take that percentage times 500, and it will tell us how many grams of gold there would be in 500 grams of gold 3 chloride. So again, we need to have the molar mass. Gold 3 is an Au3. Chlorine is a Cl minus 1. You're going to switch and drop for an AuCl3. The total molar mass, we have 1 gold and 3 chlorine for a total molar mass of 303.32 grams per mole. We only are worried about the mass of the percentage of the gold in this case, so that we can find then the mass of the gold in the 500 grams of the gold 3 chloride. We don't have to find the percentage of the chlorine, just the gold. Our total mass of gold is 196.97 over the total molar mass of the gold 3 chloride times 100 gives us the percent of the gold in 5 significant figures this time as 64.938%. Now, the next part of this is to take that 64.938% and figure out how many grams that would be in the 500 grams of the gold 3 chloride. So all we're going to do is find 64.938% of 500. So you can multiply by the percent, which you're going to have to divide by 100, times the 500, and you have a total mass of 324.69 grams of gold. So if you had 500 grams of gold 3 chloride and you could extract that gold, you would end up with 324.7 grams of gold. I wonder how much that would be on the market today. All right, ladies and gentlemen, that's it for percentage composition. If you need to go back and rewatch the video and pause to get all of your work, please feel free to do so, and you have a great day.